Lavanya. I'm a graduate student in University of Maryland. So for the course which I took this semester, Autonomous Robotics, I basically have to build a mobile robot which is sitting right in front of me. So in this video, I'll be basically talking about the construction, the working, the slam, the grand challenge, the problems which I faced during the course, and everything that I learned so far from the course. So let's get started to the video. Talking about the construction work of the mobile robot, this mobile robot has 4 wheels and 4 motors attached to it, and these motors are driven by the motor driver. The motor driver which we are using here in this project is basically 298N. This motor driver is based on the very popular L298 dual H-bridge motor driver integrated circuit. The circuit will allow you to easily and independently control 2 to 4 motors of up to 2 ampere each in both directions. We also have a servo motor which is attached to the gripper, and the gripper stands right in front of the robot. So the power supply for the servo motor comes from the H-bridge, and the gripper closes and opens according to the PWM signals and a change in the duty cycle. So, how the robot is being controlled. To control the robot, we need a processor. The processor which we are using here is Raspberry Pi. Raspberry Pi is basically a mini computer that acts as a brain for the robot. It sends signal to the motor controller and receives signal back from the sensor that are placed in the robots. Well, how we are giving commands to the Raspberry Pi? We are giving commands to the Raspberry Pi through the Python scripts, and we are also using OpenCV for a perception part. The model of the Pi which we are using here is model B+, and we are running it in SSH Putty terminal and VNC viewer. The sensor which we are using here is nothing but the ultrasonic sensor. Ultrasonic sensors emit the ultrasonic waves and receives the wave reflected back from the target. Ultrasonic sensor measures the distance to the target by measuring the time between the emission and the reception. So if you see here closely, there is a black disk which is called encoders. So we are using 2 encoders for 4 motors. Encoders are nothing but electromechanical device that converts a motion into sequence of pulse trains. These pulse trains are later converted to position measurements. These encoders are mounted to the output shaft or the motor shaft. In our case, it is mounted on the motor shaft. As the encoder disk turns, the Hall effect sensor outputs logic high when it sees the north pole and outputs logic low when it sees the south pole. Each encoder has a specific encoder counts with which we can tell the robot to move for a particular distance. For one of the assignments given to me, I calculated the number of ticks as per revolution given data as 960. So by calculating the number of revolution, I programmed the robot to move for 1 meter in a straight line. In one of the other breadboard connection, we are just connecting Arduino and the IMU. IMU are nothing but the inertial measurement unit sensor which we are using here is BNO055. This is nothing but the multi-axis sensor that allows you to measure the orientation, velocity and the gravitational forces, as it's a combination of accelerometer, gyroscope and the magnetometer. The Arduino which we are using here is nothing but the Arduino Nano, and it is programmed through Arduino IDE. So, multiple tests were conducted to test the robot in various conditions. First, I tried to run the robot with just the encoder values. Then the tests were also conducted to make the robot run with encoders count as well as the IMU values. So we are basically prepping our robot to perform on the grand challenge. So the main aim of the grand challenge is to make the robot autonomous and allow it to perform certain tasks. Our robots are designed to pick and deliver vaccine according to the QR code shown. So each QR code represents a vaccine, and the vaccines are represented by the color blocks. So for example, if the QR code detected is Pfizer, then the robot has to go and pick the red vial, which in our case is nothing but the red color block which I'm coloring here. So after picking the red color block, the robot has to localize itself and deliver the right vial in the injection area. So after 3 months, the day of a virtual grand challenge finally comes. this is my setup for my arena grand challenge. This is my wilds with which my robot has to pick, and here's the arrow with which my robot has to localize itself and goes right here, and this is the injection area, and it has to come back to its original position. So my grand challenge run was basically a disaster. I couldn't able to perform well, and it was definitely not the output I expected. So I was had the whole day because I was not able to perform it well. But later I realized why don't you give it another shot? And this time it kinda works. So though my output is not so perfect, it was definitely better than the grand challenge, and my robot has definitely showed a lot of improvements in my grand challenge. So I'm in the process of learning. So in future maybe I'll put more effort and to make it more accurate and more autonomous. So to conclude the video, I would say that ENPM809 T autonomous robotics is a course which is so much interesting than I thought. Because me, especially to me, being an electrical and electronic engineer in my undergrad, I had so much fun working with the motors, resistors, Raspberry Pi, and everything again. And it basically taught me from different perspective. Like for example, I learned a lot about planning, perception, and also the localization, and also gave me a detailed orientation about the autonomous world. So keep learning, have fun. Bye bye. Thank you.